Hello students, welcome to my channel Vision Unlimited. In this video, I will be handling another topic from the chapter Real Numbers Class 10. So before starting with the actual topic, let us discuss what are factors and what are multiples. We all have done these topics in junior classes. What are factors of numbers and what are multiples? You all know that factors means they're smaller than the actual number which you are factorizing. And multiples means, as the name suggests, it is a multiple. It is a multiple, so it is but obvious it is bigger than the number for which you are calculating the multiples. Now factors, suppose you want to calculate factors of 8. Factors of 8 are 1, 2, 4 and 8. All these are factors of 8. Every number is a factor of itself and 1 is a factor of every number. That's all we have done in our junior classes. 1, 2, 4, 8 are factors of 8. Suppose I want to write factors of 6. It will be 1 is a factor of every number, 2, 3 and 6. 1, 2, 3, 6. Now see here, when I'm talking about factors, it is less than or equal to the actual number. But when I'm talking about multiples, suppose I want to write multiple of 8. It will be 8, 16, 24, 8 3s are 24, 8 4s are 32, 8 5s are 40 and so on. All these which come in table of 8 are multiples of 8. Suppose I want to write multiples of 6. It will be 6. Every number is a multiple of itself. 6, 12, 18, 6 4s are 24, 6 5s are 30 and so on. All these are multiples. It is very clear. Factor means smaller and multiple means bigger. So after this, I am moving to the actual topic which is given in your book, that is LCM and HCF. Now what is LCM and what is HCF? As the name suggests, you have calculated LCM in your lower classes. LCM means least common multiple. Least common multiple. So it has something to do with multiple. It is least common multiple. So, but obviously, as it is related to multiple, so LCM of any two numbers will be bigger than the numbers for which you are calculating. And HCF, as the name suggests, it deals with highest common factor. So it has relation with factors. So factors are smaller than the numbers. So it means when you are calculating HCF, it is smaller than the numbers for which you are calculating the HCF. LCM is bigger than those numbers for which you are calculating, and HCF is smaller than what you are calculating. Okay. Firstly, let us take some examples and calculate LCM and HCF. Suppose I want to calculate LCM of 18 and 24. 18 and 24 I want to calculate LCM. Easiest method to calculate LCM or HCF is to firstly do the prime factorization. Firstly, I will be discussing with you how to calculate LCM. Before coming to calculate LCM, let us do prime factorization. In the last video, we have learned how to do prime factorization. You have to write the number and break it in terms of its factors. So 18 is a even number. So let's start with 2. 2 9s are 18. 9 is odd number. 3 3s are 9. 3 1s are 3. So prime factorization of 18 is 2 into 3 ka square. What about 24? Let us factorize 24. 24 is again even number. 2 1s are 2, 2 2s are 4. Again even number. 2 6s are 12. Again even. 2 3s are 6. 3 1s are 3. So 24 की prime factorization we have got 2 का cube into 3. We have got prime factorization of both the numbers. Now in order to calculate LCM, what we have to check? We have to write all the factors which are coming in both the factorization. All the numbers which are coming in both the factorization. 2 and 3. Here they are having common numbers which are coming in both 2, 3. Here also you are getting 2, 3. So LCM will be given by, you have to write all the numbers which are coming in factorization. So you have to write it like this, 2 into 3. Then as the name suggests, LCM, least common multiple. Multiple के साथ relation है, it means multiple is bigger than that number for which you are calculating the, for which you are writing the multiples. So it means LCM is bigger. So what you have to do, you have to write the highest powers of the factors. All the factors. Here you are getting only two factors. So 2 का यहाँ पे power क्या है 1, and here you are getting power as 3. So you have to write here as 3. Now what about 3? 3 का power यहाँ क्या है 2, and here you are getting 1. Which one is bigger? 2. So you'll write 2 here. So LCM is 2 का cube into 3 का square. 2 2s are 4 2s are 8 into 9 is equal to 72. So 72 is the LCM of 18 and 24. If by chance you will get 5 here, suppose you are doing prime factorization from other number and you will get 5 here, and here you will get 7. As I told you, in LCM you have to write all the numbers. No doubt 5 and 7 are not coming out to be common, but if you are calculating LCM, it will come out to be 2 into 3 into 5 into 7. No doubt that 5 and 7 are not common, but still you have to write 5 and 7 here, because I told you that you have to write all the numbers which are coming in factorization, and you have to write their highest powers. Here highest power is 1, so 5 will remain as it is. 7 ki highest power is 1, so 7 will remain as it is. 2 ka cube and 3 ka square. So this will be your LCM. Next comes HCF. Let us calculate LCM and HCF of the same numbers 18 and 24. Already we have done the prime factorization. Now let me tell you how to find HCF. As the name suggests, HCF is smaller. HCF is smaller than the numbers for which you are calculating the HCF. So 18 ka prime factorization is this. Now in HCF, you have to choose only common factors, not all the numbers, only common factors. So for HCF of these two, common factors are 2 and 3. So 2 into 3, as the name suggests, it deals with factors. It means it is smaller one. So you have to choose the smallest power, 2 raised to power 1, 2 raised to power 3. So here you will write smallest power, that is 1, and 3 ki smaller power is 1. So HCF of these two numbers is 2 into 3, that is 6. Got it? Now we'll discuss some practical applications. You all must be worrying why we are studying all this. What is the fun of studying all this LCM and HCF? Where it can be used in real life. If it is not used in real life, then what is the fun of studying it? Okay, just a minute. Okay, let me take one example. Of a school. Two schools are running side by side. They are having adjoining wall. They are having adjoining wall. So bell ringing in one school can be heard by the students of other school. Okay. Now what happens in first school? This is school number 1 and this is school number 2. In first school, each period is of 30 minutes, and in second school each period is of 20 minutes. It is playway school, so here each period is of 20 minutes. Here period is of 30 minutes, and here just a minute, here in first school period is of 30 minutes, and in this school period is of 20 minutes. Now school starts at 8 a.m. Both the school starts at 8 a.m. in the morning. It means bell for first period rings at 8 a.m. It is for the first time that bell is ringing together. Now my question is, at what time the bell will ring together after 8 a.m.? 8 a.m. के बाद कब बेल एक साथ बजेगी दोनों स्कूल की? चलिए, let us see how to calculate this. Let me help you how to think for this problem. For this first school, next bell will ring at 8:30, and for this school bell will ring at 8:20, and for this school next bell will ring at 9, and for this school next bell will ring at 8:40. For this school next bell will ring at 9:20, and for this school next bell will ring at 9. So it is very clear, next bell will ring together at 9. After 1 hour, they'll ring together. Clear? Both the schools bell will rung together at 9 a.m. together. After 8 a.m. first bell will ring together at 8 a.m. next bell will be at 9 a.m. Now how we can calculate it? By using the concept of LCM and HCF. Now question is where LCM and HCF is used. Here I have drawn the whole chart. I've just calculated. If the number is bigger, then it is not possible for me to write all the timings here and calculate at what time the bell will ring together. So in order to avoid all these calculations, which concept I will be using? First of all, in such type of problems, you have to observe this thing that bell will ring afterwards. Bell will ring afterwards means you are calculating the common multiple of both the things. See, 30 into 1, 30 into 2, 60, 30 into 2 you are getting 60, and 20 into 3 you are getting 60. So for this 3 times it is coming, and for this 2. After second bell you are getting 9, and here 20 into 3 you are getting 60, and here 30 into 2 you are getting 60. Means bell is ringing together after 60 minutes. Bell is ringing together after 60 minutes, and here you are getting in the second period, at the end of second period, and here you are getting at the end of third period. Done. It means I have calculated least common multiple of these two. 60 I am getting. And how you will get 60? By calculating the LCM of 30 and 20. 30 and 20. Let me take another example here. Suppose first bell rings in first school, bell rings after 18 minutes, and here bell rings after, here you can take an example of, instead of bell you can take an example of red light also. Light changes after 18 minutes, and here light changes after 6 minutes. I'm not taking example of traffic lights. You can take example of some other type of light. Here lights are changing after 18 minutes. Here light is changing after 6 minutes. So first light changes at 8 a.m. At what time they will change together? At what time they will change together? Yes, 18 2s are 36. I have to calculate LCM. So first 18, the next कितना आ जाएगा यहाँ पे 36, और यहाँ पे कितना आएगा 12, and next will be 6 minutes के बाद change होगा. The next is 18. 18 and next 18 तो starting में है, so it can be together. 18 के बाद में next कितना आएगा 24, and then next is 30, then you will get 36. So after this will be after 1, 2, 3, 4, 5. After 5 minutes, and this will be after 1 minute, they will be together. Okay, we can take one more example here if you want. Okay, just a minute. Okay, suppose two friends are running. Two friends are running. One is running at the speed of 3 kilometer per hour, and second friend is running at the speed of 5 kilometer per hour, and each of the friend, let me name this friend as Aman and this friend as Deep. Both the friends are running, and what they are doing, they are running on this track. This track is for Aman and this track is for Deep. What they are doing, after every 1 hour they are placing a flag. They are placing a flag, and they both start from this very position. After 3 kilometers, this Aman reaches here and he places a flag. Means this is 3 and this is 6. And for him, this is a, no, sorry, just a minute. Here it will be 0. We have to start from 0 now. So for here, it will start from 0. This is starting position. After 1 hour, Aman will be here and he will place a flag here, and next flag after 2 hours he will be here and he will be placing a flag here. And what will happen with Deep? After 1 hour he will be here at 5 kilometers and he will be placing flag here, and after 2 hours he will be at 10 kilometer. This is 5 and this is 10, and he will be placing flag here. After this ये कहाँ पहुंच जाएगा 9 kilometers, तो यहाँ पे ये flag लगा देगा. 9 he will be reaching 12 and he will be placing flag here, and after this he will be reaching 15 and he will be placing flag here. Now question is, at what position they will place a flag together. After this third minute में ये कहाँ जाएगा 15 पे, and he will place a flag here. So at after 15 kilometers they will be placing the flag together. At 15 kilometers both the friends will be placing the flag together. So how I have calculated it? 3 kilometers is here and 5 kilometers is here. So I will be calculating LCM of 3 and 5. 3 into 5. 3 is a prime number and 5 is again a prime number. So in order to calculate LCM of prime number, I have to write their product, that is 3 into 5, 15 kilometers. So after 15 kilometers, they will be placing the flag together. Okay, let me take another example. These all were examples to tell you where you can use LCM in real life applications. Next is for, just a minute. Next is for this HCF. Where this HCF is used. Okay, I'm giving you one example where you can use HCF. Now here I have taken the example of a milk container which contains 30 liters of milk. This milk container contains 30 liters of milk, and two friends are there, Aman and Deep. Again they are tired after running a distance of 15 kilometers. Aman and Deep, they both are tired and they want to drink milk. Now Aman is running at the speed of 3 kilometers per hour. So he wants to take say 5 liters of milk, and Deep, who is running at the speed of 5 kilometers per hour, he wants to take 15 liters of milk. Okay, now this container contains 30 liters of milk. Now Aman, who is running at the speed of 3 kilometers per hour, wants to take 5 liters of milk. 5 liters of milk, he is not going to absorb it alone. He is going to take it to his home and share it with his family members. Deep, again he will be taking 15 liters of milk. Okay, now my question is, using which of these containers that person who is selling this milk, he will be able to give them milk by measuring it to exact quantity. Means, like if he wants to measure 5 liters, question is that he can take only one of these utensil to measure the milk. He has went to the market and he needs to purchase only one of such type of container to measure such type of milk. He can carry only one with him, not two. So in order to measure 5 liters, he can use this. So in order to measure 5 liters, he can use this container. So in order to measure 15 liters, which container he can use? Can you use this? Use this. Because for 10 liters it is okay. बट फॉर 5 लीटर्स वी कैन नॉट से कि यहाँ तक आएगा 5 लीटर तो 5 और 5 हो गया तो इतना करके मैं इसको 5 लीटर दे देता हूँ 15 लीटर हो जाएगा. इट इज नॉट पॉसिबल. सो what he will be doing, he will be taking this container to measure these two quantities. For this Aman, he will be filling the container till the last, till the bottom, till the brim, and he will be giving it to him. And for second Deep, he will be filling it thrice and give it to Deep. So means here I have calculated 5 into 1 and here I will be getting 3 into 5. Means I have filled this container thrice in order to give milk to Deep. So how I have calculated, which concept I have used here from mathematics, which concept I have used? Yes, yes, I have used HCF. I have done prime factorization of both the numbers. 5 ka prime factorization is 5 into 1 and 15 ka prime factorization is 3 into 5. Now in order to calculate HCF, I'll be getting smaller number. So I'll be calculating HCF, that is common factor is 5. 5 ki smallest power is 1. So HCF of these two is 5. So it means he has to take 5 liter wala container to measure the capacity which Aman and Deep wants to exact number. I hope LCM and HCF is clear with example. In our next class, I will be dealing with Euclid division algorithm. Thank you.